Good old Anne. Key ideas that we've said. First of all, if I know the frequency, if I know the period, 1 over the period will give me the frequency. If I know the frequency, 1 over the frequency will give me the period. If I'm moving in a circle, my circular speed, which is at right angles to the radius, is, well, it's a variation of distance over time. It's the circumference divided by how long to go around once. That is distance over time. And then we have 2 equations for acceleration. V squared over r, which v? The circular speed, centripetal speed. Or 4 pi squared r over t squared. Which one of these do I use? Well, if they ask for or mention speed, I'll use the v squared over r. If they ask for or mention period, I'll use the other one. Now, A says, what's the radius of the circle? So I said, okay. I crossed out the 2 minutes, Karin, and said, nice try, Duick. You're not going to get me on that anymore. So I said, it looks like they gave me the period because that's how long to go around once. That's not just a lowercase t time. That's an uppercase t, go around once. And it looks like they gave me the speed. I said, the only equation that has all those in it is this one. Cleo, in this one, are there any squareds or anything? Is it easy, though, when you're copying stuff out to accidentally put extra stuff in? Also because often you folks get pi r squared as the area equation mixed up with 2 pi r as the circumference equation. So I'm just going to say, be meticulous and careful. I want to get the r by itself. Aiden, how will I move the 2 pi over? What's the 2 pi doing to the r? So, how will I move the t over? So are you telling me that the radius is going to be the speed times the period divided by 2 pi r? Sorry, divided by 2 pi? I agree with you. So if I plug in the numbers, it's going to be 170 times 120 divided by bracket 2. Make sure you know where your pi button is. And I got a pretty big answer. I was talking to Cleo about this yesterday, and I said, that's 3.2 kilometers. But I said, wait a minute, it's an airplane. It's going fairly fast, 170 meters per second. That's about, well, you can multiply it by 3.6. It's several hundred kilometers per hour. How long did it take to make the circle? 2 minutes. So start. 2 minutes is a fair bit of time. You know what? A 3-kilometer circle, that's probably about right. A 3-kilometer radius, that's probably about right for an airplane. I'm okay with that. So at first it made me nervous, and I thought about it, and I went, no, actually, I'm good with that. So 3,000, I'm going to write 3,250. If you said 3,240, I'd take a half mark off, learn to round off. B says, find the centripetal acceleration of the plane. I can either use v squared over r or 4 pi squared r over t squared. Karin, no matter what, I'm using my answer from A to do B. Which of those two looks like it's less typing? Yeah, I went with. So it's going to be 170 squared over, and then I just used my answer button. If you got A wrong, but you went 170 squared divided by your answer from A, I would give you full marks for part B. 170 squared divided by answer button. Oh, answer button. Yeah. 8.9. Almost pulling a G. Almost. Number 2. Nick, what's number 2 wanting me to find? You know what? It just wants me to find FC. That's going to be MAC. No winner minus zero. This is the equivalent of find the net force. A what force? A net force. F equals MA, except you're moving in a circle. F equals MAC. Which version of A am I going to use? The fact that they gave me a frequency, I said, I'm going to use M4 pi squared R over the period. squared. I don't know the period. I know R, 6, M, 12. The period is going to be 1 over the frequency, and they gave me the frequency in hertz. So it's going to be 1 divided by 5. 1 divided by 5. Period is 0.2. If this rotates 5 times per second, it takes 1/5 of a second to go around once. I'm going to get a pretty big number because 12 kilograms, Wes, that's about a bowling ball. Okay? 6 meters, that's about the distance between me and McKenna. So we're rotating a bowling ball on the end of a string 5 times a second on that long a radius. That's going to require a machine. Like, there's no way a human could do that. So I'm going to guess you're going to get a fairly big force in the thousands or maybe even hundreds of thousands. Let's see. 12, 4, pi squared, 6 divided by 0.2 squared. 12 times 4 times pi squared times 6 divided by 0.2 squared. Do you get 71,100 newtons? You got your timetable there, Allie? On your desk? Yeah, okay. If you got that right, 3 out of 3. For 3 marks, I would probably have given you 1 mark if I saw that, 1 mark if I saw that, and 1 mark for the answer. Cool. Josh, what's number 3 you want me to find? So they gave me a speed. I said I'm going to use the v squared over r. If they had told me how long it took to go around once, or if they had told me the frequency, I'd use the 4 pi squared r over t squared. 5 squared all over, and then they gave it to me in centimeters, which is 0.25 meters. Oh, is this 1,000 even? 100 even. 100 even? Yeah, 100 even. You're right. Just about 10 Gs. Okay. By the way, again, what if we went twice as fast? 400, not 200 meters per second squared. Okay. That's also what you're running into on that gyro toy that you're using. Those either getting to like 8,500 and you're trying to get to the 9 or the 10. That squared is biting you there like crazy, which is why I giggle so much when I see you all getting so close but not quite getting there. Ferris wheel, I like number 4, I like number 4, I like number 4, number 4. Oh, it's on the quiz. I guess that's pretty obvious. I'm going to do a bit of a dulp, so we're at the top. There's my dulp. What are the forces acting on this person? Get the obvious. Oh, this is a job for a free body diagram because they want a normal force, and there's more than one force in the question. They didn't say find FC, the net force, or AC, the net acceleration. What are the forces acting on this person? Get the obvious one. Karn, what else? Bigger, smaller, or the same size as mg? And how do I know? What path are we tracing out? Where is the bigger force always pointing? Toward the... That's what I need to get you to drum into your brain. It's very counterintuitive because when you're used to thinking, oh, I'm getting pushed outwards when I go around a corner, the bigger force must be pushing outwards. There's no force pushing you outwards. It's your own inertia. In this case, though, there is some normal force keeping this person from sinking into the chair. What's my equation then? Yes. MAC. You know what? They gave me the period, so I could have gone straight to M 4 pi squared R over T squared. Don't forget the M, because force is mass times acceleration. Common mistake, kids forget to put the M there because that 4 pi squared R over T squared looks so complicated. Surely that must be a force. No, it's an acceleration. Now it's a force. Do the M's cancel? No, and on normal force, they never will. It's why bigger people feel the forces more. It's why as you get older, if you get heavier, you may age out of some rides. You may find, I don't like that ride that I liked when I was a little kid anymore. We're trying to find the force that the bench exerts. Karn, which force are we really trying to find? Swappy dance. mg minus m 4 pi squared r over t squared. And do you mind, Karn? I'll put the Fn right there. By the way, that's your normal. That's what all of you are feeling right now. So will this person feel heavier or lighter at the top? Why lighter? Because we're subtracting something from their normal. Yeah. And this is, you do feel lighter. Again, Ferris wheels are pretty tame rides. The one at Playland actually goes reasonably fast compared to some of the other ones I've ridden on at like carnivals or in other parks or something like that. The Disneyland one, Disneyland has a big Ferris wheel. The outer one is pretty tame. It also has ones that swing along railings, that's a very different physics, an oscillating thing. Okay, let's crunch the numbers, Mr. Duick. M, 65. 9.8 minus 65 times 4 pi squared 9 all over 25 squared. I have no idea what the answer here is. What was that? Did I type that in right? mg minus m4 pi squared r over t squared. Is it almost exactly 600? Yeah? That's a fluke. I'll take that. Nice answer. Just for giggles, if I divide by 9.8, at the top, they feel like they weigh 61 kilograms. Not a big difference. No, a Ferris wheel is a pretty tame ride. Okay. In fact, what scares people more on the Ferris wheel is the swinging of the car, not the going in a big circle. In fact, going in the big circle, most people quite enjoy the view. History of Ferris wheels is pretty cool. The first one was built by a guy named George Ferris. That's why it's called a Ferris wheel. It was built for the Chicago World's Fair in, I think it was 1890. And for the longest time, it was by far the largest one built. It was about 75 meters high. It was about 8 stories tall, and it was a wonder. Each car held 36 people, and there was, I think, 36 cars. Like it held several thousand people. People lined up for hours and hours to go on it because Chicago at that time, the tallest building was 3 or 4 stories. You were seeing the entire city of Chicago. It was large enough that he had to borrow a lot of money to build it. The banks thought he'd go bankrupt. He made a mint off of it. It was large enough that actually half of the East Coast steel supply was used to build it. So Ferris wheels are pretty cool. Now we're back. Oh, at the bottom, I'll do again a slight dulp. What are the forces acting on this person? Get the obvious one. What else? Why did I draw normal force bigger? What path are we tracing out? Where is the bigger force always going to be pointing? Towards that. By the way, also, does FC ever show up on my free body diagram? No. The winners and the losers show up. In the same way, MA never showed up on your free body diagram. It was the winners and the losers that showed up, okay? Who's winning? Normal force. Who's losing? mg. What's that going to equal? m4 pi squared r over t squared. So to get the normal force by itself, I just do that. In fact, I think if I'm clever, if I bring back this line and just change the minus to a plus, is it 674? If you got that, 3 out of 3. Otherwise, for both of these, I would give you 1 mark for that, 1 mark for that, 1 mark for the number. So 1 mark for that, 1 mark for getting the plus mg over, 1 mark for the answer. Five. Ooh. First of all, roller coasters. Cool. There's going to be either a Ferris wheel or a roller coaster, or maybe both on your test. We're at the top. It wants to know how fast. I'm already thinking I'm going to be using the v squared over r. All right. What are the forces acting on this person? Get the obvious one. What else? Which way? Yeah. So I'm going to get this equation. winner plus winner equals mv squared over r. Do I know m? Okay, it's like mg is not a problem. Do I know the normal force? I do. It's 4.5 times their weight. How do I calculate someone's weight? mg. Okay? Don't get mass and weight confused, Wes. Weight is the force of gravity. mg, the obvious one, that's weight. So 4.5, oh, okay. It's going to be 4.5 mg plus mg equals mv squared over r. Hey, what is 4.5 mg's plus 1 mg's? I'll do that. 5.5 mg's equals mv squared over r. Here the m's do cancel. So everybody would feel 5.5 times their weight, or 4.5 times their weight, because all of you are used to feeling 1 mg, so you'd be feeling an extra 4.5. What do they want me to find? How fast? Oh, square root of GR with a 5.5 in front of it. But the fact that there's a square root of GR, I probably did this right. Square root of 5.5 times 9.8. What was the radius? 11. You get 24.3? Yeah? Okay. After the first loop, the riders hit a second loop. At the top of the second loop, so same free body diagram, the rider is traveling 16 meters and feel a normal force of twice their weight. What's the radius of the second loop? So I'm going to argue it's the same free body diagram. I think it's going to be the same equation. Normal force and gravity equals mv squared over r. I'm going to get the r by itself eventually. We feel a normal force of twice our weight. I guess 3 mg's equals mv squared over r. Oh, cool. How would I get the r by itself? Yeah, where is the r right now? On the times it to the top and divide the 3g over. I think, Karin, I'd get this. The v squared would stay where it was. The r would move to the top on the left, and the 3g would drop down there. Okay, so v squared, 16 squared, all over 3 times 9.8. So this would also be if you were trying to design this ride and you wanted them to have twice their normal force at the top of the loop. Now again, I pointed out to you, nobody builds circular loops anymore. They build what's called a clothoid loop, which tends to look like a teardrop shape. The closer that is to a circle, the bigger the G's the riders will experience. You get 8.71? For 4 marks, I'd give you 4 out of 4 if you got the right answer. Otherwise, I would probably go 1, 2, 3, 4. Okay? So for a roller coaster loop, as far as I'm concerned, don't hand it in. I'm actually just going to collect the scores. I want you to be able to hang on to these to study from. So if the person at the end of each row can rip out a scrap piece of paper, write their name, write their score, pass it inwards. For a roller coaster question, then, as far as I'm concerned, I can either give you any 2 of speed, radius, and normal force and ask you to find the other one.